On this one, the state of Pennsylvania says that if more than 7% of households in a city exceed the safe limit of whatever's in the water, the city needs to switch to bottled water. After some news reports of acid rain, the concerned citizen takes a random sample of 100 households around the community, finds that 12 have unsafe water. Do the data provide convincing evidence that this should be Pennsylvania, by the way, PA community should switch to bottled water? All right. I guess it's West Allegheny. That's what that stands for. Anywho, so we're going to start where we picked up left off yesterday. We're going to write the null and the alternative based on this question, okay? So the null hypothesis, first thing I have to decide, is this a percents question or a means question? Percents. How do you know? Because it literally says 7%, doesn't it? All right. So I'm going to use P. And 7%, 0.07. And there's an equal sign in the null. And then the number is the same in the two hypotheses. Then it says, do the data provide convincing evidence that they should switch to bottled water? What does that mean? Does that mean greater than 7% or less than 7%? Yep, because if you don't see it, it says because if greater than 7% if more than 7% exceed the safe limit, that's where we're seeing that, okay? So this one is a greater than. Now, some people may look at this and like, well, where's the less than fit in here, you know? Sometimes you need the other side of the logic, because wouldn't it be true that if it's less than 7%, that would be safe? Because aren't we saying in the null that this is safe and this is unsafe, right? So we could write it as less than or equal to is safe. That's legal, not a problem. Just know that the equal part only can go in the null. That make okay sense? And it helps in these questions where you have to do a lot of context stuff, okay? All right, we're going to use alpha 0.05. They tell us this right here. We're going to need that. All right, so after conducting a test, a p-value of 0.025 is found. So we're going to interpret this p-value. All right, this is that big old sentence we worked on yesterday. We always start it with assuming the null is true, but in context. So remember, what is the null? That the water is safe, right? Assuming the water is safe, there is let's put that in, 2.5% chance of getting, now what was the sample here? It said 12 out of 100 households, so that would be 0.12, wouldn't it? Of getting a p-hat of 0.12, and then would I say or greater or less than? If you're not sure, look at your alternative. What did you use there? Or greater, didn't we? We used a greater than. So 12.12 or greater. And then the finishing touch, by random chance alone. Okie doke. Now we make a decision. Reject or fail to reject. Well, go back to that p-value. It says 0.025. We compare it to alpha of 0.05. Is it less than or greater than? It's less than. What did we say? If the p is low, we reject the whole. So we're going to reject the null hypothesis. All right, what does that mean practically, though? If we're rejecting the null, are we saying they're keeping the water or getting bottled water? Remember, null means safe, right? We're rejecting this. So we're saying you need to go buy bottled water, aren't we? Okay, so we're saying they need to switch to bottled water. All right. So far, so good? Now, what if we made a wrong decision? Bum, bum, bum. What happens now?
Dead babies.
What?
Because,
We made a wrong decision. We said it was.
all those poor children.
We said the water. No, we're saying we the water is. We're rejecting the null, saying the water's not safe. You need to go get bottled water, but we're wrong. The water is actually safe.
Okay, well, all those dead babies, because all the money
You were fixated on dead babies
all the money
today.
spent to buy the bottled water could have spent giving them food, and they starved.
So we went out and bought bottled water we didn't need. Everybody there?
Yeah.
Don't focus on the babies thing. She's on to that. So we all bought bottled water we didn't need to. So so here's the question. It says, suppose the decision is wrong. What is the consequence of this error? You will see this, okay? Okay. Bottled water was purchased.
Remember the toilet paper? Assimilated.
Unnecessarily, yes. Oh gosh, I can't spell. I spell unnecessarily. There it is. Let's see. Unnecessarily. So all this money was spent on water we didn't have to go buy, right? Is that a problem?
Yeah.
Would you be annoyed by it? Yes, of course you would. Now, this is what we call a type 1 error. And type 1 happens when you reject the null. If it's a wrong decision and you rejected the null, it's a type 1. Okay?
The hope is good.
The hope was good, yes. Now, if the water was safe, the probability of making this kind of mistake is equal to the alpha, the significance level. And what is the alpha level they told us to use? Look at number 1. It's up there. It's 0.05. Okay? So the probability of making this mistake is 0.05. And here's some of the logic, okay? So we just said that since it's a greater than, we would shade on the right tail, wouldn't we? That area is 0.05. We also call that the rejection region. So when we're running our test, if our z-score falls in that region, that means we reject the null. So what's the probability of the z-score falling in that area? 5%, because it's 5% of the whole thing. Does that make sense? All right. Now, let's switch gears. Let's pretend that the p-value was 0.217. How does that compare to 0.05? It is greater, isn't it? And what did we say we do if it's greater? We fail to reject the null. All right, now practically speaking, we failed to reject the null. So we're saying the water is safe. What happens next? Do they keep the current water or they go buy bottled water? Okay, they're going to keep the current water. Now, what if that's a wrong decision?
It's dangerous to health.
Very dangerous to your health, right? If this is a wrong decision, then people could get sick. Sick/die. I'll put that in there for you, okay? That's a bad decision. We don't want that kind of error, do we? No, we don't. Now, this is what we call a type 2 error. How do I remember this one? Well, it's cheeseball, but it works. Type 2 because it's failed to reject. Ooh, deep thoughts, right? Deep thoughts. Failed to reject is a type 2. So you just look at your conclusion. Did I reject or fail to reject? And that will determine what kind of mistake you might have made. Will we know? No, but we have to think about what's the consequence of our mistakes if we do them. So what's the consequence? We said people get sick or die, right? So number 4, so which is worse? The consequence of a type 1 or the consequence of a type 2? Type 2. And it's always that way. No matter what the scenario, type 2 errors are more detrimental. Really. Type 2 errors. Why is it more detrimental? People's health is more important, right? Than the money. All right. People's health is more important than money. Oh, I'm so glad you asked. We're going to get there. Next page. Before we get off, maybe you're still struggling with type 1, type 2. Let me give you a couple memes because they're everywhere. Nope. Type 1, you're pregnant. Nope. Type 2, you're not pregnant. Yeah. Yes, oopsies. Right? Both mistakes. Right? Both are mistakes. Maybe that's not clicking for you. Try this example. Remember the little boy who cried wolf? Type 1 error. There's no wolf, but the villagers incorrectly reject it. They thought there was, so they went after him, right? Not a big deal, but type 2's problem, because the null was that there is no wolf, but they incorrectly accept the null, which we don't accept, by the way. That makes me go, we're not allowed to say accept the null. We can only reject it, or fail to reject. So, but that's a problem, right? If the boy's getting eaten by the wolf, that's a problem. There you go.
It builds character.
It does build character. I can appreciate that. All right. Ready to move on? Good. All right, let's look at this. So this little table, I do talk about this in the video. If you haven't watched it, you will. This is just the table of the decisions we can make when we run a hypothesis test. We either get it right or wrong, don't we? We either reject the null or fail to reject the null. So here it is. If I reject the null, but the null was true, that is a type 1. If I reject the null because the null's false, I made a good decision. If I fail to reject the null and the null was true, that's a good decision. If I fail to reject the null, but the null was false, that's a type 2 error. Alrighty? So then we're going to have to be able to put these in sentences in context, okay? So a type 1 error is when the null is true, but we rejected the null. It's a mistake. And what do we say the probability of a type 1 is?
It's the same as alpha.
It's alpha. It's alpha. So, and here's kind of the sentence that we're going to use when we explain a type 1 error. The null hypothesis is true, so put this in context. Don't say the null hypothesis. But we find convincing evidence for whatever the alternative is in context, okay? Type 2 error is when the alternative is true, but we failed to reject the null. Failed to reject the null. Same idea here in the alternative. We put it in context. Context. Okay, let's try this out. The new example. Here we go. Mr. McBurney purchased a trick coin that's supposed to land heads up 75% of the time. One of the students volunteered to test the claim. So the student flips the coin 50 times, and he finds that the coin lands heads up 35 out of 50 times. So his sample is what? 70% of the time, even though it claims to be 75. The student then performs the test at the, notice the alpha value of 10% level, where P is the true proportion of tosses that land heads up. All right, we all good with that? So, type 1, type 2 error, describe it in the setting. So here we go. Type 1. Type 1 error means we rejected the null, but the null was true. So we would say the coin works as expected, because that's what the null means, right? The coin works as expected, but the student found evidence that it is not working. So his sample's just bad, right? Student found evidence that it's not working. Type 2. What's the truth with the type 2? The alternative's the truth, isn't it? So we would say the coin is faulty. You can spell faulty. It's faulty, not working correctly, however you want to phrase that. But the student finds evidence that it is working fine, right? Or as expected. More than one ways you can phrase this correctly, but you've got to get your null and your alternatives in the right places, all right? Okay. Which type of error is going to result in Mr. McBurney wanting to return the coin and writing a negative review? Type 1, right? Because it's working, but the student says it's not. The student sample is, he says it's not. So this would be type 1. It's annoying. There is a consequence, but it's not a big deal. Now, look at this. If the student were to use a 5% significance instead of 10%, would this make it more or less likely to reject the null? So here we go. We were starting over here. Oh, sorry, it's a less than. So this is going to be a left tail test of 10%, right? That's where we started. So our probability of a type 1 was 10%. We're changing it, however, to be 5%. So what's happening to this area over here in the tail? It's smaller. It's getting smaller. So my probability of making that error is smaller. It's smaller. Make a little sense? Groovy.